What is a term of a polynomial and how does it determine the degree? Imagine you're building a puzzle and each piece is a part of a larger picture. In algebra, that puzzle piece is called a term. A term of a polynomial is a single part of the expression that includes a number called a coefficient, a letter called a variable, and a number called an exponent. For example, in the polynomial 3 times squared minus 2 times x minus 10, the terms are 3x squared, minus 2x, and minus 10. Each of these is separated by addition or subtraction signs. Now each term can be broken down into 3 parts. The coefficient is the number in front, like 3 and 3x squared. The variable is the letter, such as x, which stands for an unknown or changing value. The exponent is the small number above the variable, like 2 and x squared, which tells us how many times to multiply the variable by itself. For a term to be part of a polynomial, the exponent must be a whole number that is 0 or higher. The degree of a polynomial is like the highest mountain in a range. It is determined by looking at all the terms and finding the one with the largest exponent. That largest exponent tells us the degree. For example, in the polynomial 3x squared minus 2x minus 10, the highest exponent is 2, so the degree of this polynomial is 2. If the polynomial only has a constant, like 5, then the highest exponent is 0, and the degree is 0. If the polynomial has a term with an exponent of 1, like for x plus 7, then the degree is 1. Knowing the degree helps us understand how the polynomial behaves. A polynomial with degree 1 is called a linear polynomial, which makes a straight line when graphed. Degree 2 is quadratic, which makes a U-shaped curve. Degree 3 is cubic, which can have an S shape. The degree tells us how complex the polynomial is and what kind of graph it will produce. So, a term is like a building block of a polynomial, and the degree is found by looking at the term with the highest exponent. This simple idea helps us classify polynomials and predict how they will act when we solve or graph them. Understanding this makes working with algebra much clearer and more straightforward.